Imagine you're stargazing on a clear night. You see stars, planets, maybe a galaxy. But what if I told you that in the time it takes you to blink, a blast of energy more powerful than millions of suns just flashed across the universe? And we have no idea what's causing it. This isn't science fiction. This is the reality of fast radio bursts, or FRBs, the universe's most mysterious signals. And today, we're diving deep into what we know, what we don't, and the mind-blowing theories trying to explain them. So what exactly is an FRB? Picture this. A signal, a burst of radio waves, travels for billions of years across the cosmos. It's incredibly bright, outshining everything in its galaxy for a fraction of a second. And then, it's gone. Poof. Vanished. The entire event lasts for just a few milliseconds. That's thousands of times shorter than the blink of an eye. The first one, the Lorimer Burst, was discovered back in 2007, but it was found by sifting through old data from 2001. At first, astronomers thought it might be a glitch, a mistake, maybe even a microwave oven in the observatory kitchen. I'm not kidding. They actually traced some weird signals back to a microwave. But as more and more of these bursts were detected by different telescopes around the world, it became clear. These signals were real, and they were coming from deep space. One of the most fascinating things about FRBs is what they tell us about the journey they've taken. As these radio waves travel through space, they pass through gas and plasma between galaxies. This intergalactic medium slows down the signal, but it affects different frequencies differently. Lower frequencies get delayed more than higher frequencies. By measuring this dispersion, we can calculate how much stuff the signal has passed through. It's like a cosmic breadcrumb trail. And what it tells us is that these bursts are coming from incredibly far away, from galaxies billions of light years from Earth. They aren't local phenomena. They are truly cosmological. This makes them one of the most powerful and distant events we've ever observed. Now for the billion-dollar question. What creates them? This is where things get really exciting and a little wild. The sheer energy packed into a millisecond burst is staggering. It requires an extreme, cataclysmic event. For a long time, the leading theory was that FRBs were one-off events, like two neutron stars colliding or a black hole swallowing a star. These are destructive, spectacular events that would only happen once, and for many FRBs, that seemed to fit. We'd see a burst from a specific point in the sky, and then silence. We'd stare at that spot for years and hear nothing. This supported the idea of some kind of cosmic explosion. But then, in 2016, everything changed. Astronomers found an FRB that repeats. It was sending out bursts over and over again from the same location. This discovery threw a wrench in the cataclysmic event theory. An explosion can't happen twice in the same place. Suddenly, we needed a new explanation, something that could survive creating these immense energy blasts and do it again. The search for the source of this repeating FRB led astronomers to a tiny dwarf galaxy about 3 billion light-years away. It was a huge breakthrough. We finally had an address for one of these cosmic mysteries. The discovery of repeating FRBs opened the door to a whole new set of theories. And the leading suspect right now is a type of neutron star called a magnetar. Magnetars are the most magnetic objects in the known universe. Their magnetic fields are trillions of times stronger than Earth's. They are cosmic monsters, spinning rapidly and incredibly dense. The idea is that starquakes on the surface of these magnetars, or powerful flares from their intense magnetic fields, could release the enormous energy we see as an FRB. In 2020, this theory got a massive boost. For the first time ever, a fast radio burst was detected from within our own Milky Way galaxy. The source was a known magnetar. It wasn't as powerful as the FRBs from other galaxies, but it had all the right characteristics. It was like finding a fossil of a baby T-Rex after only ever seeing adult skeletons. It confirmed that magnetars can, and do, produce FRB-like signals. This was a monumental discovery, linking a specific type of object to this mysterious phenomenon. Many scientists now believe that at least some, if not all, FRBs are caused by magnetars. But the story doesn't end there. The mystery is far from solved. While magnetars are a great explanation, they don't explain everything. For instance, some repeating FRBs have a pattern. One famous repeater, FRB 180,916, seems to follow a 16-day cycle. It's active for about 4 days, then silent for 12, then repeats. What could cause a magnetar to have such a regular schedule? One idea is that the magnetar is orbiting another object, like a star or a black hole. Its bursts might only be visible to us at a certain point in its orbit. Another theory suggests the magnetar's rotation itself could be wobbling, like a spinning top, causing its beam to sweep in and out of our line of sight. And what about the non-repeating FRBs? Are they also from magnetars, perhaps from a younger, more volatile stage? Or are they something else entirely? Could the original theories about colliding neutron stars still be correct for some of them? The universe is a big place, and it's entirely possible there's more than one way to make an FRB. It might not be one single phenomenon, but a whole class of different events that all produce these millisecond flashes of radio light. This is where we are in 2026. New, powerful telescopes like CHIME in Canada and FAST in China are detecting FRBs almost daily. We're moving from discovering them one by one to building a massive catalog. We're finding them in all sorts of different galaxies, big spiral ones like our own, and small, weirdly shaped dwarf galaxies. Each new discovery adds another piece to the puzzle. We're also using FRBs as tools. Remember that dispersion effect I mentioned? By studying how FRB signals get stretched out, we can map the cosmic web, the faint, web-like structure of gas that connects galaxies across the universe. It's like giving the universe a CT scan. FRBs are illuminating the vast, dark spaces that we couldn't see before. So, where do we go from here? The next big step is to find more FRBs in our own galaxy. If we can study them up close, we can finally pin down the physics behind these events. We also need to pinpoint the exact locations of many more distant FRBs. Are they all in star-forming regions? Are they near the centers of galaxies, where supermassive black holes lurk? Or are they scattered randomly? The ultimate goal is to catch an FRB in the act, not just in radio waves, but in other types of light, like X-rays, gamma rays, or even gravitational waves. A multi-messenger detection would be the holy grail, giving us a complete picture of the engine driving these incredible bursts. From a strange signal in old data to a revolutionary tool for cosmology, the story of fast radio bursts is a perfect example of how science works. A mystery appears, theories are proposed, new data challenges them, and slowly, piece by piece, we get closer to the truth. We still don't have all the answers, but the hunt is more exciting than ever. Every day, astronomers are listening to the static of the cosmos, waiting for that next millisecond flash from billions of light years away, a message in a bottle from the most extreme corners of the universe. What they find next could rewrite our understanding of physics. Thank you so much for joining me on this deep dive into the cosmic mystery of fast radio bursts. If you enjoyed this journey and want to stay updated on the latest discoveries from the universe, make sure to hit that subscribe button and turn on notifications. What do you think is causing FRBs? Let me know your theories in the comments below. Thanks for watching, and keep looking up.